A 60 milliliter cylinder is filled with a mixture of an unknown element M and CO2 to partial pressure of 3.07 atm and 37.2 atm respectively, and a temperature of 30 degrees Celsius. The cylinder is heated to a high temperature at which the binary compound MXCl(Y) is produced. The cylinder is then cooled to a temperature at which CO2 is a gas and the binary compound MXCl(Y) is solid. The remaining CO2 gas is transferred to another 60 milliliter cylinder where the pressure at 30 degrees Celsius is 28 atm. Assuming that the unknown element M has reacted completely, find the empirical formula of the binary compound MXCl(Y). In order to find the empirical formula, we need to find the amount of moles of each element used. So we are going to start with the unknown element M, which has the pressure of 3.07 atm, a volume of 6 milliliters, but we need it in liters, so that makes 0.0600 liters, a temperature of 30 degrees Celsius, but we need that in Kelvin, so we add 273.15, which gives us 303 kelvins, and we need constant R, which is 0.0821 liters atmospheres over moles K. We're going to plug all of this into our equation PV equals nRT, but since we're looking for moles, we rearrange it, giving us N equals PV over RT. We plug this into our equation, so we do 3.07 atm times 0.0600 liters over 0.0821 liters atm over mole K times 303 K, which gives us 0.00740 moles of M. We are going to do the same thing we did for M for Cl2. The pressure is 37.2 atm, volume is 6 milliliters, but we convert to liters, which is 0.0600 liters. The temperature is at 30 degrees Celsius, but we add 273.15 and we get 303 kelvins, and we use the constant R, which is 0.0821 liters atm over mole K. We plug this into the formula, so we get 37.2 atm times 0.0600 liters over 0.0821 liters atmospheres over mole K times 303 K, which gives us 0.0897 moles of Cl2. Now we do the same thing for the Cl2 remaining. So we have a pressure of 28 atm, volume of 60 milliliters, which we convert to 0.0600 liters, a temperature of 30 degrees Celsius, and we add 273.15, which gives us 303 K, and our constant R, which is 0.0821 liters atmospheres over moles K. We plug this into the equation, so we do 28.0 atm times 0.0600 liters over 0.0821 liters atm over mole K times 303 K, which gives us 0.0675 moles of Cl2. In order to find the amount of moles of Cl2 we do the starting, which is 0.0897 moles of Cl2, minus the remaining, which is 0.0675 moles of Cl2, and it gives us 0.0222 moles of Cl2 used. Now that we know the number of moles for M and Cl2, we can use these to find the empirical formula. So we're going to take the one that's smaller and divide it by both numbers. Since M is smaller, we're going to use M's number of moles and divide it into both. So for M, we're going to do 0.00740 moles divided by 0.00740 moles, which gives us 1. For Cl2, we're going to do 0.0222 moles divided by 0.00740 moles, which gives us 3. Now that means that we have 1 M and 3 Cl2s, which gives us Cl6. And the empirical formula is MCl6.